None of you are old enough to know the significance of this title. In 1968, a famous letter was written to the communications, the ACM, by Dijkstra, who said go-to statements are considered harmful, and he made the case for why go-to statements made programs harder to understand. I'm going to claim that what we're doing as far as models in requirements engineering, except I call up development. I don't use that engineering word, software development. Maybe we'll get to engineering, I don't know. But they're incredibly simplistic, I discovered, way late into my research. So I'm going to show you why I think so. I hope all of you will kind of skeptically consider what I have to say. I don't think all of it's wrong, but possibly some of it's wrong, except I'm unable to spot the bugs in what's going on here. So my hope is that I will help you, give you a few useful things that you can take back and do possibly a better job in your workplace, and perhaps even share some of the things that you think might even be interesting. Okay, understanding complexity. Well, the word complex, right? We know what that means. We know what simple means. But what does simplistic mean, you might ask? Well,
the Australian jewel beetle is dimpled, glossy, and brown. The female is flightless. The male flies, looking, of course, for a hot female. When he finds one, he alights and mates. There's another species in the outback, Homo sapiens. The male of this species has a massive brain that he uses to hunt for cold beer. And when he finds one, he drains it and sometimes throws the bottle into the outback. Now, as it happens, these bottles are dimpled, glossy, and just the right shade of brown to tickle the fancy of these beetles. The males swarm all over the bottles, trying to mate. They lose all interest in the real females. A classic case of the male leaving the female for the bottle. The species almost went extinct. Australia had to change its bottles to save its beetles. Now, the males had successfully found females for thousands, perhaps millions of years. It looked like they saw reality as it is, but apparently not. Evolution had given them a hack. A female is anything dimpled, glossy, and brown. The bigger, the better. Even when crawling all over the bottle, the male couldn't discover his mistake.
He had a hack, right? He had a model of the female. A little to do with the actual females, and then the model failed big time. I mean, that's a true story. Okay, so simplistic means, right, that it's too simple, that it's not helpful, and simplistic sells. Now, this is about the 150th anniversary of one of the most successful models out there, the periodic table. Now, there is an incredibly useful model. It helped people identify where there were holes and said, maybe there's actually something there. And they went off and, my goodness, they found something they didn't know existed. So the model really helped them big time, right? For 150 years. That's super, super valuable stuff. We, you and I, all have oversimplification bias. We prefer simple solutions. We prefer unconditional statements. Politics is filled with this. If we only did A, B, and C, the world would be a wonderful place and this problem would be gone. Yeah, we hear a lot of that these days. There are a couple of things going on. One is our preference for simplistic models, and two is our infinite ability to deny reality. We say, oh, that piece of evidence, I'm going to ignore it. I'm going to filter it out. So here we have, something's just not right. Our air is clean, our water is pure, we get plenty of exercise, everything we eat is organic and free range, and nobody lives past 30. Maybe there's a few other factors there that are important. Okay, we often oversimplify. The easiest model is once upon a time there was the flat earth. Actually, there are people today that believe there's the flat earth. I don't know what percent of the population that is, but it's there. Then we had a round earth at the center of the universe, and everything revolved around us. Yeah, no egotism there. Then somebody said, wait a minute, let's try a new model where we got the sun at the center, and we got all these other things out there that we've named going around. But the problem here, see if I can go back one. Yeah, the problem here was if you were predicting the next eclipse, your math was really ugly. It was filled with all kinds of hacks. You had a factor, somebody said, what's that about? Well, I can't quite get that calculation correct with this model that the Earth is circling the sun. And then a guy named Kepler came along and said, how about ellipses? Ooh, that made it a lot easier, right? So it progressively got to something close. Is it a pure ellipse, a pure mathematical ellipse? Probably not. So there's probably still a few hacks in the calculation of the next eclipse. All right, for every complex problem, there's an answer that is clear, simple, and wrong. Because simplicity sells. Clarity sells. We love all that. Ideas should be made as simple as possible, but no simpler. We got that little phrase at the end there. That's really important. Okay, now I included this only so you can download it from the website. This is a beautiful thing about, this is the research in the upper right-hand corner, and then as we go around the loop here, things get simpler and simpler and simpler and simpler. I found that just the other day. Reality is much more complex than many imagine or want to believe, and you all know what Occam's razor is, but sometimes Occam is wrong. Sometimes there is actually somebody out there trying to get me. Requirements development is much more complex than many imagine. And how do I know that? Because I'm going to show you 3 simplistic models that are at the heart of requirements development. And there are 90,000 people that have been certified by 4 different organizations based on these 3 simplistic models. Now, what is a model, right? It represents some aspect or set of aspects of something we care about. And it's easier to think about, analyze models than it is the thing itself. So H2O, that symbol itself, is a model. And if we want to show the relationship of the oxygen to the hydrogen, we get even more information. We get the 2 H's and the O and their relationships. A simplistic model omits important aspects of what it is we're trying to focus on. There is an international standard. That's what ISO, International Standards Organization, right? You go, wow, this all over the world, really smart people came together and they created a model of quality attributes. And functional, where did non-functional requirements, I love that phrase. That's like, let's study human beings. We're going to have men and non-men. That isn't going to get you really far. So we've got, these are examples of the simplicity that I'm talking about. Okay, so once upon a time I decided to draw a line and put simple on one end and complex on the other. That was my first mistake. That was too simplistic. It worked really well for simple because we had triangles and E equal MC squared, and I'm not claiming that that's necessarily simple, but as an equation we understand it. And we even understand the benzene ring because it's got a pattern that we grasp. Once we see the pattern, yes, I can remember that. It fits in our brain, right? Small, simple things fit in our brain. But what happened when I tried to go on the right side and do complexity, it split into three kinds. The first kind was called essential complexity in a paper by Brooks. And he talked about essential complexity, meaning everything that's in the model needs to be there, and there's nothing extra in the model, right? So necessary and sufficient, that old kind of stuff from mathematics. So we got the London Underground, and we've got DNA and general relativity, okay, as examples of essentially complex models of the thing we're talking about. Now, we've got some unnecessary complexity. Spaghetti code would be an example. The U.S. tax code with 4 million words in it. We got necessary and sufficient. We got sufficient, but some of the stuff is unnecessary, and guess what? The number 3 is, right? So here we're going to move now into the notion of the models in requirements. So how about the different types of requirements? Well, we got functional and non-functional. That's pretty simple and useless. There's a model you'll be seeing in a couple of minutes that is a requirements model. It's got 19 different types of requirements. They're not all on your project, but they help you think. And you go, any of this, is this relevant to anything I'm doing? Oh, it is, yeah. I would have overlooked it if I hadn't thought like that. Okay, now we have insufficient complexity or simplistic complexity. You've probably not heard that phrase before. Simplistic and complexity, what are those two words doing together? It means whatever you're trying to model, you haven't gotten there yet, right? You haven't gotten to essential complexity yet. So we have the Sweebach model, which is the functional and non-functional guys. They're all over. I don't want to beat on the Sweebach. I mean, software engineering body of knowledge. We got lots of different places in which these simplistic models show up. The best-selling book on requirements engineering has 4 types, okay, as opposed to the 19 you're going to see. Okay, so how about quality models? That's that ISO standard I mentioned a moment ago. The particular quality model I'm going to drag you through at the beginning in the next session has over 30 characteristics for each quality. The ISO standard has what? The name. Okay, well, that's good. I mean, it's like a list, and you can go, is this relevant? Not. If it is, you're done. The model isn't going to help you anymore except by identifying things that might be relevant to you. So here we have, in my estimation, insufficient complexity to get the job done, and I will argue what that's about. The software development process itself. Sweebach says there are 4 activities. We've got to go out and elicit requirements, and it gives you, several ways to do that, and then there are 3 other things, and we're going to show you a different model of what you need to do to when you're doing requirements development, what you and your teams need to do, and it's more complicated than that. Okay, so requirements development is, in my view, full of, these are 3 basic activities in software engineering, and if we haven't got them modeled anywhere near the level of complexity they actually are. Now, let's talk about risk. I don't know whether you folks hear a lot about risk on your job, but DeMarco and Lister think that risk management is project management for adults. That means if your projects are being managed properly, somebody's saying, what could go wrong? They're taking people out for beers and whatever it is to find people who have experience, who have scar tissue, What's this from? Oh, let me tell you about that scar. And then they tell you things. You go, oh, I didn't even know that could happen. Not only can happen, but it's likely to be very bad. So let me see what I can do about it to avoid it happening at all, or to mitigate, right, to reduce the pain involved if it actually does happen. That's all called mitigation, right? So we got hazards and mitigation. And it's really important that we know these things. So one of the many risk management tactics is if you got stuff out there that's too complex, you got to simplify it. So that would mean doing something like taking excessively complex code and refactoring it. Where did that word come from? I mean, factor is a perfectly nice word in mathematics. Refactor. That means it was factored once, maybe. Some code I've seen was never factored. It was just ugly and virtually unreadable. When necessary, you've actually got to complexify. Where'd that word come from, right? That doesn't roll off your lips. You've never heard that before. Complexify. I need to make some of the models that I'm using in my job more complex than the simplistic ones that were given to me. Simplistic models limit your understanding. You may overcome them. Somebody might say, hey, we're interested in safety. Safety is important. And somebody else might raise their hand and go, what about security? Oh, are they related? Why, yes. Security supports safety. If you're doing safety, you got to be doing security. How do I know that? Not from most of the models that are out there. It was a great discovery. Well, no. How about if you have a somewhat accurate model of the relationship between qualities, then when you realize you get the ones that are really fragile and hard to achieve, one of the reasons they're fragile is because there's a bunch of others that are supporting them. And you got to pay a lot of attention to that too. You can't manage what you don't understand.